Ever wondered when life could have first appeared in the universe? It's an intriguing question that has intrigued scientists, philosophers, and curious minds alike for centuries. The origins of life, not just on our home planet, but throughout the vast cosmos, is a topic that is as mysterious as it is fascinating. And the implications? Well, they're immense. Not only does this question challenge our understanding of life itself, but it also forces us to reconsider our place within the grand theater of the cosmos. Throughout this journey, we'll delve into the conditions necessary for life to emerge, the early conditions of the universe, the formation of stars and planets, and the tantalizing possibility of Earth-like worlds existing billions of years ago. We'll even touch upon the search for extraterrestrial life and what future explorations could reveal. Let's journey back in time to explore these fascinating possibilities. What does life need to emerge? That's a question that has intrigued scientists for centuries. As we delve into this mystery, we'll find that the ingredients for life are both simple and complex, ordinary and extraordinary. First and foremost, water is a vital ingredient often referred to as the elixir of life. It acts as a solvent, a medium allowing biochemical reactions to take place. It's no wonder that our search for life beyond Earth often starts with a hunt for water. However, water alone isn't enough. Life also requires a stable environment, one that doesn't swing to extremes of hot and cold or bombard its inhabitants with lethal doses of radiation. This stability allows life forms to adapt, evolve, and flourish over time. But what about the building blocks of life itself? Life as we know it is carbon-based, with carbon atoms forming the backbone of complex molecules like DNA and proteins. Carbon is versatile, capable of forming bonds with many other elements, creating a vast array of potential molecules. Along with carbon, life also needs other elements like hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These elements, often referred to as knops, are the most common elements in all life forms on Earth. They are the raw materials that, when combined in the right way, give rise to the incredible complexity and diversity of life. But there's one final, often overlooked ingredient: time. Life doesn't just spring into existence overnight. It's a slow, gradual process, taking billions of years to evolve from simple, single-celled organisms to the vast array of complex life we see today. These elements set the stage for the miracle of life. But how and when these ingredients came together in the early universe, giving birth to the first life forms, is a tale as old as time itself. A tale we're just beginning to unravel. The early universe was a vastly different place than it is today. Let's take an imaginative journey back in time, to a period just after the Big Bang, when the universe was a hot, dense point no larger than an atom. As the universe expanded, it cooled down, allowing the first particles to form: electrons, protons, and neutrons. These particles combined to form the first element, hydrogen, and its isotope deuterium. As the universe continued to cool and expand, helium, another light element, was also formed. This process is known as Big Bang nucleosynthesis. These light elements, hydrogen and helium, made up the early universe with traces of lithium and beryllium. Now fast forward a few 100 million years to a period known as the Cosmic Dark Ages. The universe was filled with clouds of hydrogen and helium gas, but there were no stars or galaxies yet. It was during this time that the first cosmic structures began to form, driven by the gravitational attraction of dark matter. As these structures grew, they pulled in more and more gas, growing denser and hotter. Eventually, these gas clouds collapsed under their own gravity, forming the first stars and galaxies. These early stars were much larger and hotter than most stars today, and they burned through their fuel quickly. The nuclear reactions in these stars produced heavier elements like carbon, nitrogen, and oxygen, which are essential for life as we know it. When these massive stars exhausted their fuel, they exploded in spectacular supernovae, spewing these newly formed elements into space. These elements, scattered throughout the universe, would later coalesce to form new stars and planets, including our own solar system. The early universe was not hospitable to life as we know it, but it set the stage for the creation of the elements necessary for life. The early universe set the stage for the creation of the elements necessary for life. Stars are the factories where the elements necessary for life are made. This isn't just a poetic phrase, it's a scientific fact. You see, the universe didn't start with a full periodic table. After the Big Bang, we only had hydrogen, helium, and a dash of lithium. So where did all the other elements come from? The answer lies in the heart of stars. In their fiery cores, stars perform a process called stellar nucleosynthesis. This is where lighter elements like hydrogen and helium are fused together under extreme pressure and temperature to create heavier elements. Everything from carbon to iron is produced this way. But what about elements heavier than iron, like gold or uranium? Well, that's where supernovae come in. A supernova is the explosive death of a star, and it's one of the most powerful events in the universe. In this cataclysmic explosion, the conditions are just right to create elements heavier than iron. The explosion also scatters these newly minted elements into the surrounding space, where they can eventually form new stars and planets. And that's how we end up with a universe rich in a diversity of elements, including those necessary for life. So the next time you look up at the stars, remember that you're looking at the cosmic factories that made life possible. Without stars, the elements that make up life as we know it wouldn't exist. Not all stars are created equal when it comes to supporting life. This statement might seem surprising, but it's a fundamental truth when we start to consider the possibility of life beyond our home planet. To understand this, we must first delve into the concept of habitable zones around stars. A habitable zone, often referred to as the Goldilocks zone, is the area around a star where conditions are just right, not too hot, not too cold, for liquid water to exist on the surface of a planet. This is crucial as we know, at least based on life on Earth, that water is a key ingredient for life to thrive. But let's rewind a little. Before a planet can find itself comfortably nestled in a habitable zone, it needs to form. Planets are born from the same clouds of gas and dust that give rise to stars. These cosmic nurseries, called nebulae, collapse under the pull of gravity, creating a spinning disk of material. At the center, a star ignites, while farther out, particles in the disk begin to stick together, gradually forming the planets. In the early universe, this process was happening everywhere, but not all of these planetary systems would have been hospitable to life. The type of star at the center plays a significant role. For instance, red dwarfs, the most common type of star in the universe, have habitable zones much closer in than our suns. This proximity makes planets more susceptible to harmful radiation. On the other hand, larger, hotter stars might have habitable zones farther out, but their shorter lifespans might not provide enough time for life to develop. So when we talk about the possibility of life in the early universe, we're looking for a kind of cosmic sweet spot, the right kind of star with a planet at just the right distance. The right star and the right distance can make all the difference for life. It's a delicate balance, a cosmic dance of sorts that makes the universe and our existence within it all the more fascinating. Could Earth-like planets have existed in the early universe? This question catapults us into an intriguing exploration of our universe's history, one that might just redefine our perception of life's beginnings. The early universe was a very different place to what we see today, but that doesn't necessarily rule out the possibility of Earth-like planets. In fact, the seeds of these planets could have been sown in the very early stages of the universe. The first stars started to form around 100 million years after the Big Bang. This is when the universe began to cool down and the first atoms formed, creating the cosmic dust and gas clouds that eventually collapsed under gravity to form stars. In the vicinity of these early stars, dust and gas swirled into protoplanetary disks. These disks, rich in elements like silicon, oxygen, and iron, are the birthplaces of planets. Over time, solid particles within these disks began to stick together, forming planetesimals, the building blocks of planets. But what about the conditions necessary for life as we know it? One key factor is the presence of water. Early Earth-like planets would have needed a stable environment where liquid water could exist. This not only requires a suitable distance from their star, within the habitable zone, but also a protective atmosphere to maintain the right temperature and pressure. Another crucial aspect is the presence of the right chemical elements. Life as we know it is carbon-based. Carbon, along with other key elements like nitrogen and oxygen, are the products of stellar nucleosynthesis. These elements were spread throughout the universe by supernovae, enriching the interstellar medium from which new stars and planets formed. So could Earth-like planets have existed in the early universe? While we can't say for certain, the potential is certainly there. The early universe had the ingredients and the processes necessary for the formation of such planets. We're still learning about this fascinating period of cosmic history, but one thing is clear: Earth may not be as unique as we once thought. Are we alone in the universe, or is there life out there? This question has intrigued humanity for centuries and has given birth to a fascinating field of study known as astrobiology. Astrobiology is the science of life in the universe. It seeks to understand the origin, evolution, distribution, and future of life, not just on Earth, but across the cosmic expanse. In our quest for life beyond Earth, we have focused our attention on exoplanets. These are planets that orbit stars other than our Sun. Thousands of these celestial bodies have been discovered in the last few decades, and the number keeps growing. Each discovery brings with it a sense of anticipation and excitement. Could this be the one that harbors life? The potential habitability of an exoplanet is determined by a myriad of factors. The most fundamental of these is the presence of liquid water, a key ingredient for life as we know it. The planet's distance from its parent star, its atmospheric conditions, and its geological activity also play crucial roles in its ability to support life. In this regard, the concept of the habitable zone, often referred to as the Goldilocks zone, becomes crucial. This is the region around a star where conditions are just right, not too hot, not too cold, for liquid water to exist on the surface of a planet. But finding an exoplanet in the habitable zone is just the beginning. We then need to look for signs of life, known as biosignatures. These could be anything from certain gases in a planet's atmosphere to changes in its surface, or even signals of an intelligent civilization. The search for extraterrestrial life is not an easy task. It requires patience, perseverance, and cutting-edge technology. But the rewards are potentially enormous. If we do find evidence of life elsewhere, it would revolutionize our understanding of our place in the universe. The universe is vast, and the search for life continues. Each new discovery brings us one step closer to answering that tantalizing question: are we alone, or is the universe teeming with life waiting to be discovered? What does the future hold for our understanding of early life in the universe? As we continue to venture into the cosmos, a number of missions and projects are on the horizon that promise to expand our understanding of early life in the universe. These missions are being designed with the specific intention of exploring the potential habitability of exoplanets. In the next decade, we can expect to see groundbreaking advancements in our ability to detect and characterize exoplanets. We're not just looking for any planets, we're looking for those that fall within habitable zones where conditions might be just right for life as we know it to exist. With the advent of next-generation space telescopes, we're on the cusp of being able to identify the atmospheric compositions of these distant worlds, a feat which could provide us with vital clues about their potential to host life. Imagine the possibilities. A new world, with an atmosphere rich in oxygen, perhaps even traces of water vapor, could be a strong candidate for life. Or maybe we find a planet with an atmosphere full of methane, potentially indicating the presence of biological activity. Every new discovery will help us to piece together the puzzle of when and where life could have emerged in the cosmos. But it's not just about finding exoplanets. Future missions will also seek to further our understanding of the processes that could lead to the formation of life. This includes studying the role of cosmic radiation in triggering chemical reactions, or understanding how life's building blocks might survive and be transported through the harsh environment of space. As we stand on the brink of these future discoveries, we cannot help but reflect on how far we've come. The study of early life in the universe is a field that has only emerged in the last few decades, yet it has already transformed our understanding of the cosmos and our place within it. While the journey to find answers is filled with challenges and uncertainties, it is also one of the greatest adventures of our time. This quest for knowledge pushes the boundaries of science and technology and fuels our insatiable curiosity about the universe we live in. While we may not have all the answers yet, every new discovery brings us one step closer to understanding when life could have first appeared in the universe.